Greetings, everyone. On behalf of the GeneBank platform and the Crop Trust, thank you for joining us for today's GROW webinar. I'm Yanni Van Beem, and with me is Faye Wambua Ludeling, who is co-moderator for this presentation. I'm very pleased to introduce our speaker today. Dr. Amber Hartman Scholz is Deputy Director of the Leibniz Institute DSMZ, the German collection of microorganisms and cell cultures in Germany. She headed the team that led to the DMZ becoming the first registered collection under the Nagoya Protocol in the European Union, demonstrating the collection's voluntary compliance with EU Regulation 511 of 2014. She was also the head author on the combined study on digital sequence information in public and private databases and traceability, and she is currently leading a German-funded project called Wild DSI on DSI and open access. Her broader work at the DSMZ focuses on internationalization, strategic development, and science policy. Dr. Scholz has broad experience in science and policy through her work in the United States at the White House Office of Science and Technology Policy and the National Cancer Center, and as a science fellow to the California State Senate Environmental Quality Committee. This month's GROW title is Digital Sequence Information, a Looming Disaster or Hidden Opportunity for Positive Change. Welcome, Amber.
Thank you, Yanni. It is super to be here. I really appreciate you all giving me the invitation to be here today. Let me share my slides real quick. Greetings to all of you, those that I've had the opportunity to meet before, and those that I haven't yet met. Good day, good afternoon, morning, wherever you might be. I want to give a quick disclaimer before I launch in. I know there are some of you out there that are yourselves digital sequence information aficionados or experts or ABS experts. And I always know there's this challenge in these very technical fields of giving the big overview for those that are somewhat new to the field or have less exposure versus boring those of you that are deep experts. And so what Yanni and Faye asked me to do here for the GROW webinar was to give a very broad overview, recognizing that a number of attendees might have only limited access or limited exposure to ABS and DSI issues. So for those of you that are experts, sit back and relax and kind of wait for the Q&A. With that kind of disclaimer, let me get started on this sort of intentionally provocative title, Digital Sequence Information, a Looming Disaster. You know, are the bad things ahead, or potentially even an opportunity for change? So I have to take you kind of back to 1992. I think that's a really simple place to start. The Convention on Biological Diversity, and I think as biologists or those of us interested in the life sciences, this is something that we have to sort of keep in our hearts when we think about the issues here. Number one, it is trying to turn around the sixth mass extinction that is happening to species on our planet. So number one goal of the UN Convention on Biological Diversity is first the conservation of biological diversity. The second goal is the sustainable use of its components. So similarly, not using things up, for example, fish in the ocean, faster than they can be replaced by nature or by us, for example, in agriculture. And third is always kind of, for those new to the field, the mystery, right? The fair and equitable sharing of the benefits from the use of genetic resources. So for example, right now I'm here in Florida, where my parents live. And when they ask me, you know, what are you doing about your at work, actually, what do you do during the day? And I explain, oh, I work on this, the third goal, the third objective of the CBD. And I explain that, they're like, what? What does that even mean? And it's completely understandable. And the better way perhaps to look at this, it looks so simple on paper, is that this is the political balancing act. The fair and equitable sharing of the benefits is the compromise between the parties of the world, the countries of the world, to say, this is how we create an internal motivation to conserve and to sustainably use, by saying to countries that are low and middle income or are economies in transition, if you do this, you should get something back from people that come and use your resources. And therefore, in a next step, you have an intrinsic motivation to conserve and to sustainably use your biological diversity. And I think it's important to sort of recognize this was a political horse trade, if you will, to create a sort of internal motivation and to give something back to create a motivation, basically. And another important note here is that while it has near universal signatories across the world, one very important country is missing, the United States of America. And by important, I just mean simply in terms of numbers, in terms of the scientific enterprise there. And when we come to think about digital sequence information, we'll learn more from the maps about where the US is relative to the rest of the world. So when we look at what happened since 1992, we see that the decline of species as measured by the IUCN, the International Union for the Conservation of Nature, and their Living Planet Index, that the loss of species has continued since 1992, right? So then parties sort of said, that agreement that we came up with in 1992, not quite enough. And so as we get further along this curve, there becomes a growing pressure to create yet another mechanism to actually do a better job, a stronger job of reversing the species loss. And then when you look across the planet, you actually see that some regions, for example, South America, that trend line is even more stark than, for example, in North America, meaning that you really need to look for more regional types of targets, ultimately, if you want to reverse species loss. So if you flash forward in history, then still a decade ago for us here now, to COP10 in October 2010, there was yet another horse trade that was made. In German, we call it a Kuhhandel, so we say cow and not horse. I have no idea why. And that is essentially what brought us the Nagoya Protocol and the Aichi targets. So the Aichi targets tried to break this biological diversity loss problem down into 20 different targets. And they categorized them and they sort of said, like, here's the next way that we are going to address species loss on this planet. And tried to do a better job of doing regional or broken down goals. And this became, the Aichi targets are also part of the strategic plan. At the same time, in order to facilitate these commitments from parties, the parallel negotiations at COP10 were around the Nagoya Protocol, a legally binding mechanism to implement Objective 3 of the convention. Because parties had been complaining for a long time, look, biopiracy is happening, people are not asking permission before they take our biological resources out of country or utilize them, and we don't think that's fair, and so we need a better mechanism. And the goal really of the protocol is to provide legal certainty for all actors, providers and users, and to specify concrete ways to share benefits arriving from the utilization. What you need to know about it, what's really important when I talk to academic researchers, there is still a great misunderstanding here. It applies to every kind of biological component, if you will. It does not apply to morphological features, but it does apply to all organisms. So plants, animal, fungi, microbes. There's exceptions for the plant world, which probably many of you know about, but in general, it applies to all organisms. Biochemical compounds included, they're called derivatives, which is maybe not a great word if you're a biologist, but the policy world calls them derivatives, including metabolites and proteins. And then also all nucleotides, so DNA and RNA. And importantly, it's clear that it's the molecules themselves. And what we're going to get to is whether or not the sequence data, the digital data, is or is not part of that package. Importantly, it is also non-commercial and commercial. Many people believe that the protocol applies or is focused on commercial use of genetic resources, but that's not true. If you're doing taxonomic research and you are using organisms, you are still under the protocol. And that's created also a lot of tension over the last few years. There's a relatively complicated procedure that scientists need to follow to comply with the CBD and the Nagoya Protocol. I should note that even for parties that are not, or countries that are not party to the Nagoya Protocol, many can still have CBD related procedures in place. Costa Rica is a good example here. Brazil was for many years, although they became a party to the Nagoya Protocol in June of this year. And essentially you would start with your research project. You would ask yourself, based upon information available in the ABS clearinghouse, is this an ABS, an access to benefit sharing case? If it's not, you might still have other permits that might apply. For example, if you're working in a national park or a protected area. And if it is, you would need to identify the contact information for those countries in the Convention on Biological Diversity Secretariat's website, which is called the ABS Clearinghouse, so an official, UN-sourced website. And there, in theory, should be the contact information and even ideally the procedures for compliance, although the information available in the clearinghouse is relatively heterogeneous, which makes, again, compliance somewhat challenging. And then the protocol says you would need to obtain 2 different kinds of documents, although they may or may not be 2 different documents, or they could be multiple documents. And the acronyms that you see here are prior informed consent and mutually agreed terms. Also kind of tricky because a lot of universities, technology transfer offices, and indeed the International Treaty for Plant Genetic Resources and Food and Agriculture uses the term MTA. So the same letters, but with the A and the T reversed. Then a lot of people think they're looking for an MTA, where actually in the Nagoya space, they should be asking for mutually agreed terms. So again, you see kind of the different pieces that you have to keep in your head. Then you actually get to do the sampling, and then from your cooperation partners, then you might actually get to this MTA that your university requires. This is very common. And then you might have reporting requirements. I've gone through this in detail to sort of outline that the process is not totally straightforward. And it can be very difficult if you're a beginner in this field to do this. And in fact, one of the projects that I lead at the DSMZ is a German Nagoya help desk project, which is to help users that are at the beginning of this curve, this learning curve, to implement that. And that's a separate topic that I'm not going to have more chance to talk about today. Oh, I should have been clicking along the way, apologies. And of course, I also like to note, and this topic will come back again when we talk about DSI, that if you do not require ABS permits, and if you don't require other permits, the path to compliance for your biological research is really simple. And so essentially the countries that require strenuous ABS are in a free market and competing with countries where the red line happens, meaning it's a really simple path to compliance. And that's just important to note when we think about the tensions that researchers face when trying to decide, if they have a choice, where to conduct their research. And Sylvain Albright had a really nice review last year that pointed out some of the complexities specifically for your sector, for the agriculture or the plant research sector. And that is that you all have a lot going on here. So you have the international treaty. That's probably, for most of you working in gene banks, the primary area that you'll intersect with ABS. And actually, you're probably in a relative to a microbiologist like me that supervises a lot of international projects where we're strictly under the Nagoya Protocol. You probably have a relatively facilitated system because you have the SMTA, the Standard Material Transfer Agreement. You have the Annex 1 treaties, and then you have your multilateral system, which is slightly broader, but still relatively standardized. Importantly, as Sylvain points out in his paper, you also, if your organisms don't fall in this block here at the top, you do slide into the CBD and Nagoya Protocol world, where you need these documents and where the standardization is not happening. And of course, you can also slip into CBD and Nagoya space, even if you're using Annex 1 plants or MLS plants or accessions. If you use those organisms not for the purposes of food and agriculture. So if you were, for example, in collaboration with a group to look at, let's say, cosmetics, there's some cream that you can make with oats, I don't know, I'm making it up, then actually the utilization of that resource would then fall into the Nagoya Protocol space. So that's also a tricky thing that the plant researchers have, is to really understand your legal space around access and benefit sharing, recognizing that as soon as you start to work, for example, on the microbes on your plants or use them for non-food and agricultural purposes, then you slip into this other treaty space. So you have to have, as gene bank managers, a very good kind of understanding. And I'm not going to spend any more time on those legal separations, but really encourage you to read this really lovely review in that context and other good citations there. So now moving forward again to COP15. So you kind of see on these round numbers that you get major decisions. So what's happening at COP15 in the space of the CBD, it was supposed to be in May of 2020 in Kunming, China. It now looks like it will be in May 2022 in Kunming, China because of the pandemic. We now continue to face biological loss, biological species loss, diversity loss, and many parties expect and anticipate another horse trade. And that is to say, the exchange or the parallel negotiation of the global biodiversity framework. So it's called the post-2020 Global Biodiversity Framework. We don't call it that anymore. We only call it the GBF because it's now definitely post-2020, and we're still waiting on the pandemic to let us meet internationally. And this framework should set goals for until 2030, until the next big hallmark convention, and actually outline a path towards 2050. And in order to reach the political consensus around the GBF, DSI is being negotiated in parallel as a sine qua non, an absolute sort of requirement to reach agreement on the GBF. And I'd like to tell you a little bit more about that. So basically what happened is the IG targets that were negotiated in parallel to the Nagoya Protocol, as I mentioned earlier, were not successful. So you don't need to read the text on the graphic on the right, you just need to see the number of red arrows. You can see how unsuccessful the IG targets were. Meaning parties want to try again, try harder, be more concrete, actually introducing for the first time quantitative indicators for biodiversity loss, set regional goals, be more specific. And because the IG targets weren't a success, it's sort of like, well, then we need another horse to trade in order to get greater agreement on the GBF. And that's where digital sequence information comes in. So the topic of whether or not the sequence data that arises from genetic resources should or should not be part of access and benefit sharing is the question that's in the air. And it can be really hard to understand when you hear all this alphabet soup of meetings and you hear different things are happening and different decisions, to know exactly what the status is. So to make a long story short, the question of whether or not sequence data is legally part of the international framework for access and benefit sharing under the CBD, that is an undecided question at this point. Many observers believe that after COP15 it will be decided, but it is currently undecided. It was originally brought up in Cancun, Mexico, the topic or the question of DSI at COP13 in 2016. After that, there was an initial study on DSI done by Sarah Laird and Rachel Weinberg and published in 2017 and 18, finalized in 18, and presented at the DSI AdTech, which is the Ad Hoc Technical Expert Group. That's the CBD mechanism to explore technical and contentious issues. And those results were presented at SBSTA, which is the subsidiary body on science, technology, and technical and technological advice. So it's technical and technological, double T. And importantly here, you'll see that then SBSTA goes directly into COP. What you see here that's different, if you go into COP14, where again, parties were not able to reach a conclusion on DSI, but they agreed to resolve their differences, signposting that at COP15, they would reach a decision on DSI. You see that again, another AdTech, again, a request for even more studies, again, pointing out the controversial nature of the topic because parties really cannot find an agreement here. And importantly, you see the report of the AdTech and of, in principle, also these studies, not feeding into SBSTA, but feeding into something new letters called OEG3, the Open-Ended Working Group 3, the third meeting of the Open-Ended Working Group. And the Open-Ended Working Group is the newly established body between 2018 and 2020, now 21, that negotiates the global biodiversity framework. So what you see in the architecture of these meetings is the parties showing we are not going to reach a GBF unless DSI is part of that package, right? So it's not being negotiated in parallel, it's not feeding into a SBSTA, it's feeding into the actual framework and architecture of the GBF, pointing out that it's a do or die kind of issue for the parties. And then ultimately this should be decided at the next COP15. And when we wrote this review at the end of last year, we thought it would happen in 2021, and now parties are signposting May 2022. So that's the process. Oh, I pointed out here, sorry, I forgot my innovation, the importance of OEG3 relative to SBSTA. And then here I wanted to also point out that I was the senior author here, as Faye mentioned in my introduction, for this study. And actually this is going to be the focus that I'm going to place for the next 5 or 10 minutes, on the data we gathered there. What also happened here in November of 2019 in this space, before the AdTech met and before COP15 was supposed to happen, was the Plant Treaty's governing body met in November of 2019. And I know that the Gene Bank group CGIAR was very well represented by experts there. And to make a long story short, basically because of the DSI issue, amongst others, but the DSI issue was a very, very important one that led to the collapse of the governing body's negotiations, including the expansion of Annex 1 and the simplification of the multilateral benefit sharing mechanism. And so what you also see signposted in those agreements is really that the international treaty space is kind of looking to the CBB space to see, hey, what are you guys going to do? Because our negotiations are kind of on ice until we see a signal from you. And there's sort of an indefinite hold there on those discussions, to my understanding. And again, I don't follow this space as closely as I do the CBD space. So what's happening literally right now for the last week in August and for the first week in September, you might even be seeing this flash across your news space if you follow the environmental news. You see the BBC, a headline article, Nature Crisis, Talks Resume on Global Plan to Protect Biodiversity. And that is now the OEG3 meeting that I just highlighted is happening in real time. Online negotiations, so not perhaps as effective as one might hope, but this is being happened. Of course, the news outlets do not pick up the parallel negotiations on digital sequence information, but this is really happening right now. In fact, after I leave this webinar, I'll head over and listen in again to the negotiations. And these are preparations for the GBF. And actually, if you register yourself, you can even join in if you're interested. And this actually brings me to sort of the core of what I wanted to focus on today. And that is, why is there this big call and this push for benefit sharing from digital sequence information? And it's actually, in my opinion, if you look at the data, a relatively understandable thing. If you look at when the Nagoya Protocol was negotiated in 2010, and you see on this timeline here on the x-axis, how much sequence data on the y-axis has exploded since then. The volume of data that is now available on genetic resources that in the public databases, it's pretty astounding. It's an exponential scale, log scale. And that explosion in data since that negotiation a decade ago, as well as the availability of new molecular biological tools, biotechnology tools. And of course, last year's Nobel Prize in Medicine, CRISPR-Cas9 technology, we can do as biologists a lot more than we could a decade or a decade and a half ago as negotiators handled the Nagoya Protocol and access and benefit sharing. So if you look at this table here on the left, you see these are kind of on the left side, the different tools that one might need to be able to effectively do in silico types of or synthetic biology types of research. And then the number of stars in each of these columns, depending upon the chassis that you're working in, are how advanced that technology is or how effective it is. And so you can see by the number of 3 stars, yeah, we actually have a lot of tools available in our toolkit. We still have places that we have single stars and where the technology is very underdeveloped or there's still a lot of needs. But by and large, taken together, the explosion in sequence data and the combination of powerful synthetic biology toolkits means that biologists do indeed, in some cases, although not at all across the board, but in many cases are able to work on genetic resources without having to go in country to physically access the genetic resources. And this has meant that parties in these political negotiations have said, wait a minute, the situation has completely changed since we agreed to what we agreed to in 2010. Therefore, you're messing with us, right? You don't come to our countries anymore and access our genetic resources. And therefore, we need to have benefit sharing from digital sequence data because that's where the trend is going. That's where researchers are working. And if we only get stuck with the physical genetic resources and benefit sharing from that, then we're not getting a fair end of the deal. I'm making this rather caricatured just to give you a sense of kind of how the discussions have developed. to make a long story short. However, as biologists, and the big outcry from the scientific community over the past several years is to say, oh my gosh, we have learned how the Nagoya Protocol works and that it really can be extraordinarily inefficient. And the data ecosystem around DSI is not at all like physical biological resources. For example, just some high-level statistics I've listed here for you. There are 212 billion sequences in the sequence databases from every country in the world. That data set doubles about every 18 to 24 months. So it's growing enormously, still growing exponentially. The entire data set, all 212 billion sequences, is downloaded in its entirety 34 million times a year. So all like lots of data flowing. And it's being downloaded by 10 to 15 million users that are living in every country in the world. This data is also being further manipulated in an electronic sense because it is promulgated through 2,000 downstream databases being pushed and pulled in and out of the core database infrastructure, which is the INSDC, the International Nucleotide Sequence Database Collaboration, which is 3 mutually dependent databases based in the United States, in the UK and Germany, and in Japan. And this data is cited and quoted in 500,000 publications and patent applications. So it's a very complicated, high throughput, big data world, and it is not at all amenable to the complicated flow diagram that I explained to you in the beginning about how the Nagoya Protocol works. It would literally bring the system to a freeze. And more importantly, the system is not so simple as to say it is a provider-user relationship. So most DSI does not actually come from low and middle income countries. You can see the primary source of about half of the DSI in the databases at present, this could of course change over time, comes from China, the United States, Canada, and Japan. Those are not countries except for China, where the situation is still legally unclear. Those are not countries that regulate access to their genetic resources. And so there would be no ABS claims on those sequence data. Now you do see countries that do claim access and benefit sharing, such as India, Australia, although less so recently, Mexico and Brazil, and Spain. So it is not to say that there are theoretically no ABS obligations that could arise. It's just to say that the majority is still from non-access regulating countries. There are 10 to 15 million users of this core database, and they live in every country in the world. And so you can see, for example, here, same or similar distribution of users. Interestingly here, India jumps from being a number 5 provider to being a top 3 user, which is super interesting in the context of something that the Indian negotiator said yesterday in the online negotiations, saying that low and middle income countries such as India, their users are not in a position to utilize sequence data very well. And I wanted to say, did you read the study? Because this study was officially put forth to the CBD Secretariat and to the database, to the countries. And you can see India is a top 3 country. Like, that's just not actually accurate. And I think one of the tensions that we have as scientists is to try to figure out how to make our data available to policymakers. But at the end of the day, even if you're working directly in the CBD space, as this study was, there's no guarantee that in a politically fraught space that people will listen. The infrastructure costs are also important when we think about non-monetary benefit sharing. So the infrastructure itself, it costs $50 million US per year, and that comes out to about $3 to $5 per user. And about half of the users live in countries that do not contribute to these infrastructure costs. And that means that their use, for example, Chinese and Indian users, is subsidized by those 3 governments because they don't pay the infrastructure costs. So they have what many would call non-monetary benefit sharing that comes out of these public databases. If you take those first 2 maps and you divide the one by the other, you can find out which countries actually use more than they provide. That another way of measuring perhaps non-monetary benefit sharing. And countries like Lebanon, the Ukraine, Belarus, Iraq, Colombia, Algeria, Pakistan actually use more than they provide when you look at database usage and provision of DSI. Another important note from the study was that there is still a lot of imperfection in the global databases. So actually only 16% of DSI entries in the INSDC report country information, and 44% of DSI entries did not report a country, but should have. That means the scientist that uploaded the sequence data to the databases was not completely accurate in the submission of their data. It was clear from the publication when we checked it that they had the country information, they simply did not submit it when submitting to GenBank. And only 4% of DSI entries or nucleotide sequence database entries actually link to the physical genetic resources. And collections such as mine, the DSMZ, and the gene banks such as where many of you work are very well positioned to improve the metadata that's available. And I think that that is a very important take-home message for this community to think about what part can we play. And so this overlapping piece of the Venn diagram here is where we have full metadata coverage, where we reported the country of origin of the genetic resource that has been sequenced. We link it to the publication literature, the PubMed ID in this case, and also we use our accession numbers that the collection uses and report that in the standardized fields that are available in the INSDC so that we have full transparency on the origin and location of those genetic resources. We also had lessons that we learned about the commercial use of DSI, and that is that 20% of DSI in INSDC comes from patent-associated sequence data, and it lands there because it's a direct import from the patent office. And sequence data itself is more frequently listed as a reference material than actually is the basis for the patent invention. We also found out, interestingly, for this patent data that no country information is associated with DSI in these databases. This is a huge oversight, even though it's actually often available in the patent application. It's not transferred into the database. So now flash forward to fall 2019. I have a new project that's been funded by the German government. We know there's a DSI deal that will be made someday. And we basically asked the question, how can the scientific community contribute to the process? And that's actually where we conducted a number of scientific stakeholder workshops. And we asked scientists how they use DSI, found out, of course, that it is by and large open access data. And how do they engage with benefit sharing? And we saw a variety of fields, heard from many experts of how DSI can be used from sustainable use, such as reducing waste and pig feed, poaching, wildlife trade, ecosystem research, antimicrobial resistance, a huge suite of purposes of why DSI contributes to the public good, why it needs to be open access, and we documented and summarized that. We also came up based on these stakeholder workshops with 5 requirements that policymakers should have for successful science. We said DSI needs to be open access. It needs to be a simple mechanism whenever the benefit sharing mechanism gets negotiated. It needs to learn from the Nagoya Protocol. It needs to be future-proof, meaning that it needs to account and recognize the technical complexity of the field and the doubling of the data set every 1.5 to 2 years. Needs to provide legal certainty for the users. And we said, ideally, it would even be nice if it provided an opt-in mechanism for genetic resources, meaning that for those countries that don't have ABS laws in place yet, that they could also use the DSI system for accessing the physical genetic resource before they sequenced it. We also pointed out in the paper that not all DSI is under the CBD, and we said, users use this whole data set as one big tangle of data when they access the public database. And there is data in there from many different UN fora. And we actually said, what would be really interesting is whatever the CBD comes up with, if that system were adaptable or expandable or tag-onable by other UN fora after the CBD. And we called this a universal solution, but we basically mean that it would be a real shame if scientists like you and I had incompatible DSI mechanisms that we had to deal with. And then you're back in that green box that we looked at earlier, where you have international treaty rules here, CBD rules here, CBD DSI rules here, and then plant treaty DSI rules here. Then you have 4 different mechanisms. I think that would be a huge mistake on the part of policymakers. And we basically summarized all these observations in a white paper that we wrote, which was published in October of last year. There's a 2.5-hour webinar on the presentation of the contents of that paper. And we basically presented 5 open access policy options for DSI. Micro-levy, a membership fee, which is very similar to the plant treaty proposals that were on the table in November of 2019, cloud-based fees, commons licenses, and blockchain metadata. I'm not going to have time to get into them today. I can already see we're 35 minutes in or 30 minutes in. And what was really interesting for me and satisfying is that in March of 2021, so spring of this year, the CBD Secretariat synthesized the policy options that have been written so far, including the Wild DSI white paper, and recategorized, reshuffled them, but basically came up with a spectrum of options to present to countries. So this is the current state of policy options for DSI that's out there. There's a link here at the bottom if you want to go and read through these slides more. And this suite of options is sort of the starting point for the discussions around the open-ended working group 3. I would say that there's an overlap of the options presented by the Wild DSI paper that starts basically at 2.2 and goes through 4. But they're not 100% orientated on only the Wild DSI options. What I was asked a lot in October and November when I would continue to sort of present on that white paper, which option is the best? Which one do you prefer? And I said, well, we really wanted to only provide options, plural, that were compatible with open access and that enabled monetary benefit sharing. And so we did not want to have a bias towards political decisions. We really wanted to say open access is the absolute most important thing to our community. And there are many different ways you could do it. So don't come back to us as you have in the past and say open access isn't compatible with DSI benefit sharing, but rather to give many options and say, look, you can do open access and do benefit sharing, work hard, figure it out, pick an option. But what we did say was, we think that there was still space, and what I've been doing for the last 6 to 9 months is to learn more from the data to actually inform which option would be the best. And that's what we've been doing, and recently submitted to GigaScience a publication on this. I'd like to walk you through a few slides here. So we've used the entire global DSI data set to figure out who is providing and using DSI, with the proxy for DSI use being use in a scientific publication. So take a publication, any publication. Here's one, a new virus discovered in central Bolivia. You take the first author, Christopher Cruz, and you find out the physical location of that author. So in this case, it is Peru. And then you say, what were the sequences that were cited in that scientific publication? In this case, you can see one of those scientific sequences here in accession number, all of these here in GU and other ones, but I've just highlighted one for you. And then you ask the country of origin of those sequences. In this case, it's Brazil. I should note, this is not where the virus, in this case, or where the genetic resource was sequenced. This is the physical country of origin where the genetic resource was accessed. So this is truly providing, this is not the country's location of sequencing. That's a different metadata field. And so based upon this example publication, the providing country would be Brazil and the using country would be Peru, because that's where the first author was. And based upon these data, you can actually create network diagrams to look at the use and provision of DSI. So let's take Kenya. Faye was so kind before the webinar to provide me with a list of where the attendees are from today, the 66 of you that are online, and to sort of say, here's from the top countries. So there were a number of Kenyans that were joining us today, according to the registration. And there are 79 countries that use Kenyan DSI, where the country of origin is Kenya, and some other country. For example, here you would see Sudan is using Kenyan DSI. Kenyan scientists sitting in Kenya are using DSI from 83 countries. So you see a relatively similar amount of use as you do of provision, meaning that it is not that Kenya is only a provider country and never uses DSI, but that actually both are happening in Kenya. And a similar, again, country here, Mexico is, I know, also online, or scientists in Mexico. DSI for Mexico is used by 75 countries around the world, including China, including Kenya. And scientists from Mexico are using DSI from 83 countries, a similar kind of ratio as we saw actually for Kenya. Again, similar rates, but not a one-way street where they're only providing and not using. They're using slightly more than they're providing. A number of colleagues also today from India, 94 countries are using Indian DSI, and Indian scientists are using DSI from 150 countries. So an even bigger gap between use and provision, with Indian scientists using more than they are providing. And also today, Philippines. 57 countries are using Philippine DNI, relatively small island country compared to the first three that we looked at. And Philippine scientists are using DSI from 32 countries. So here you do see a bias towards more providing than using, but again, not an entirely disparate ratio. And actually, if you take that data, providing and use, for all countries of the world, you see that there's just an actually roughly equal trend between providing and using DSI. And in fact, the green dots are the G77, the developing countries. That's a block, a trade block, if you will, of developing countries. And you actually see that relative to the yellow countries, the OECD countries, a greater amount using than providing. So that green line tends to tilt slightly below. Now, this is probably not statistically significant. We haven't done the statistical significance on this, but this actually shows you it is definitely not the case that developing countries or low and middle income countries are more providing than using. If anything, they're more using than providing. And this actually flies directly in the face of a lot of the political assumptions here that the low and middle income countries, the G77 countries, the BRICS countries tend to provide and don't use. But actually it's the reverse. They tend to use and not provide. And you can also look at this in an even more simplified way and see very clearly that DSI is used more by locals than by foreigners. So what I mean by that, if you look at all of the publications that we had in this data set on the y-axis, you can see that the biggest chunk in each of the bar graph is from that region. And so OECD users tend to use OECD sourced DSI. That's the biggest amount in this bar. Similarly, over here for G77, that is, developing countries, low-income countries, they tend to be the biggest block of users of their own DSI. And again, for BRICS, that's Brazil, Russia, India, China, and South Africa, middle-income countries. They tend to also be the biggest users of BRICS DSI. That means people tend to use the DSI that they've sourced themselves rather than going abroad and using in the databases sequence data from others. Now, of course, all DSI is used by all, but I would argue what we actually want is this block here, an OECD block of users, is 3 times more than the block here of G77 DSI or BRICS DSI. And we actually want this G77 and BRICS users of their own DSI to grow. When we think about the goals in the global biodiversity framework, when we think about how sustainable development can be enabled, those scientists in these countries need to be empowered and trained and the access maintained to the open access database to grow their use of DSI. That is to say, we want these bars to be filled in. We want these users to be using more of DSI access from their countries, both to fill in the white spots on the biodiversity map of the planet, but also to enable sustainable development. I will note that there are still 40% fewer publications, looking on the y-axis, from OECD, 40% fewer publications from BRICS and G77 users relative to their OECD counterparts. That means we still have lower scientific output and productivity in BRICS and G77 countries. And again, I think our goal as a society is probably to increase that rather than to inhibit that. And now we start to come to how do we think about policy mechanisms for DSI and picking a favorite. As a side note, I would like to say we are engaging with a number of people at the international level called the DSI Scientific Network. In the interest of time, I'm going to skip this. If you're interested in this or even interested in becoming a member, please take the time, look this up. We are actively working in the scientific space to educate policymakers on DSI and benefit sharing and open access. But what, sorry, there we go. What we've really been thinking about in this DSI network and what we've been thinking about in general is picking a favorite now of all the DSI options that are on the table. And what we've come to in the last few months in the current sort of state of our recommendation is a decoupled multilateral framework for DSI benefit sharing. And what we mean by that is a bilateral mechanism or a tagged mechanism where some DSI in the public databases has conditions on it and other data doesn't, will actually have the perverse and unintended consequence of disincentivizing the use of low and middle income countries sourced DSI, because it will inherently compete with DSI from the United States, from Germany, from the UK, where there are no access restrictions, no benefit sharing requirements. And so if you only take a subset of the DSI and you say only these sequences have benefit sharing requirements, they become the black sheep DSI and they get underutilized. And that will actually have the reverse effect on the bar graph that I just showed you, instead of actually boosting the use of those sequences, which is why our current recommendation, and when I say our, I mean the DSI Scientific Network, we believe that this access to DSI should be decoupled from the benefit sharing mechanism in order to actually create and incentivize use of the DSI, meaning you don't do an individual DSI-based, sequence-based benefit sharing, but you do data set-based sequence benefit sharing. And ultimately what we want to do is create a virtuous cycle where we recognize and incentivize national contributions, especially from low and middle income countries, rather than penalize it. We believe the core focus for a mechanism should be conservation, sustainable use, and bioeconomic innovation, and capacity building for science to improve DSI exploitation, rather than to build up some complicated regulatory mechanism, which is what was done during the Nagoya Protocol. And the current graphic that we're using right now is to maintain these open access databases to decouple the benefit sharing mechanism up here, separate from the actual access, and contributions could flow through a variety of different financing mechanisms into a multilateral fund. And what you could actually do is use the metadata from the open databases to weight and encourage to create a bonus payment system when countries have increased the amount of DSI from their country in the open databases, and say, okay, you contributed more data to the open system, then you get a bonus payment from the multilateral fund, because we want to incentivize the availability and understanding of biodiversity. And so you create this positive feedback loop that also can encourage capacity building and DSI build up use in country. And so that's really our current working model, and I'd love to take more time to discuss that or any other topic. I did not do this work alone. You never can. Many fabulous colleagues, many at IPK Gottesläben, which is also a plant gene bank that you might know of, have a fantastic database department, and then also working with the European Bioinformatics Institute in the UK, and my colleague Fabian Roden, who's now in Canada, a PhD student, that helped me with the CBD study. And with that, I'd like to say thank you. If you're interested in any of the data, it's online. Oh, and yeah, a short little plug for a new DSI workshop series that we're doing here, if you want to learn more and continue to play in the space. That was it from my side.
Wonderful. Thank you, Amber. It was really nice hearing sort of your walk down memory lane and bring us all back up to speed. That was really, really good. And some of the mechanisms that you are considering to be able to fund some of these things through a multilateral fund for DSI. So there are some questions, and I'd like to read those to you and perhaps start a discussion that way. From Michael Halewood. Hi, Amber, great presentation. Thanks very much. Regarding the stats on sources of DSI, I assume origin refers to the country from which the underlying physical genetic resource was originally obtained. Have you broken down your stats to look at origins of DSI on crops or on the 64 crops and forages in the plant treaties MLS? I assume then the countries of origin of DSI would shift a lot to developing countries.
Yeah, the very last sentence, I'm not going to guess. Always risky until you look at the data. You know that, Michael. No, but you know the great folks at IPK. And what I haven't told you yet is that we have just found out, or a couple of weeks ago before I went on vacation, that we have a new project funded called basically Wild DSI 2.0. And we will be breaking the data down even further to do a number of sector specific things. And you can imagine that the people at IPK are very interested in doing this in the plant space. We work very closely in this DSI space because of the Leibniz Association, but obviously IPK has more, international treaty ideas, and I have more CBD ideas. And so what we want to do with this data set in the next phase of the project, it's actually a new project from a legal perspective, so it's not a next phase, but it builds on the same ideas. And we want to look at the patent data, and we want to look at sector-specific use of the DSI, and in the sector-specific use, one high priority idea is the plant space. And of course, we work closely also with Neil Stein here and have very concrete ideas of how we could look at this. But without having looked into this data and splicing it yet, I don't want to comment on whether it would be or not. But I think this is exactly the cool thing about this global data set. And I should also say, if somebody wants to scoop us on it, the data is available online. I think maybe Faye even posted the link to the wildDSI.ipk.gottesleben.de. You can go online, you can download the data table already if you wanted to do this right now. Let us know if you're doing it, then we won't do it. And you could subdivide the data already right now. Mm-hmm.
Perhaps I should ask Michael if he, wants
as a follow-up,
put something on there or not. But we can move on to the second one, which is from Hannes Deppenwolf. Excellent presentation. Thank you, Amber. In terms of the horse trade that is about to happen in China, do you have a sense of what extent a likely outcome could be mandatory monetary benefit sharing on DSI, similar to what we have with Nagoya on the physical resources today? From your presentation, it clearly seems like the scientific community doesn't think this is workable. But how much sway does the scientific community really have with the negotiators here, who probably have huge incentives to get another biodiversity targets framework done?
Yeah, I mean, this is like literally the heart of the question and what keeps me up at night. I will tell you, so there's been, I think, two and a half days, I guess, depending on how you count it, of online negotiations, so only 3 or 4 hours, and I've been following them. It looks like there is broad consensus amongst the parties for open access and decoupled benefit sharing. So that last slide, I think that's going to be a red line for many countries. It seems to be not only the European Union and Canada and the UK, the usual suspects. We are also hearing strong calls for open access for the support of research and innovation from Argentina, from Brazil, from South Africa, from Mexico. We are hearing countries like Bolivia say, we want it to be a regulated Nagoya-like system. That does worry me. Bolivia has not been active to date in many of the preparatory work, and the CBD is a consensus-based process, which means they won't close down negotiations until they get consensus agreement amongst all. And so usually the way that you crystal ball what's going to happen is to look at the average, and then over time the outliers tend or get kind of forced by peer pressure to flop. But it is by no means a guarantee. And exactly because it is a consensus-based problem, even outliers, if they hold a hard line and they have no reason to flip, won't do it. Now, usually in other parallel negotiated spaces, such as resource mobilization, which is code word for money, their counterpart negotiators will eventually force them to flip because they could lose the deal if they don't, to whatever the consensus that's developing in the DSI space is. So I guess I should summarize my current impressions as cautiously optimistic that the scientific community is being represented, has been to date heard, but it ain't over until it's over. And your point is it's completely on target. It is extraordinarily important. If there's somebody out there from Bolivia that knows who the person from the Ministry of Environment is, call them up today, write them an email, go to the ABS clearinghouse and say, we don't like what you're negotiating online right now because you're representing something that is bad for science. And anybody can follow these online negotiations, and I think it's important to hold our negotiators accountable. And I must say, I have worked in close contact with representatives from the European Union and told them, represented the scientific position the best I could. And I do think that we have been understood, but it ain't over yet. Yeah.
Okay. We actually have a response for Michael Haywood. So before
or he can just turn his camera on and talk too. I see him popping up at the top. So yeah.
Can you go live? Can we allow Michael Haywood? Sorry, we're controlling.
Yeah, we're real timing it. I love it. Yeah.
Can you please unmute yourself? And then it's a long explanation, and I'd like you to do it yourself. Please go ahead.
Sorry, no, I put it in the chat because I don't know if it's relevant, and there may be other questions. So I was just adding something in if there was time for people's interest later. Anyway, I'll describe it now. Just to say that what you described as the best bet is, I think, pretty consistent with what CGIAR has been saying in these fora. And I've just included the text of what we said in the plenary earlier this week at the open-ended working group on looking at the plenary session, looking at DSI, basically saying, if we're going to have a system regulating DSI, promoting benefit sharing, it's got to be one that doesn't interrupt the free flow and interoperability of DSI. It should be multilateral in nature. It should not require pick and mat negotiated every time. And similarly with benefit sharing. So yeah, I think we're in sync, which is great. And thanks so much again. It's a terrific presentation.
Yeah, and Michael, let's follow up offline too, because maybe it makes sense for you and the IPK team and I to have a chat on thinking about the most strategic and effective way to analyze the MLS and Annex 1 plans, just that we're coordinated, and you helping us to think about where we could feed that in, because it's not going to be a difficult thing for us to do since we already have the data formatted, but offline.
Cool, thanks.
I actually have a question to follow up on what the previous question was, and that is when people were coming in, countries were coming in with their crops, the idea was that a multilateral fund was going to be created to be able to give them back some benefit sharing from the crops that they were putting into the multilateral system. That has been and continues to be a challenge. The multilateral fund does not have the funds that were expected. Now it's the DSI, which is a bigger beast with animal, plants, fungi, bacteria, and so forth. What are the chances that there is going to be a multilateral fund for benefit sharing, given that the one that we piloted, which was a smaller one under a different, very specific framework, did not really work well? What is the chance that something much larger with more countries, and something that probably needs to happen because of COVID and other things that are emerging, we need to have access as scientists? What do you think are the chances of that happening when it didn't work in a smaller scale?
Well, I think it's not that multilateral fund didn't work per se. You have to look at the architecture. It's the same problem with the Nagoya Protocol, even though it's a bilateral system. The fundamental problem of why, well, tell me if I'm wrong. The problem is jurisdiction shopping. The problem is that people know if they use older material, then there's no restrictions on it. Or if they source it from somewhere else, there's no restrictions on it. You can get plants from anywhere. And so you create, even though your system works much better than the Nagoya Protocol system, you still, even though you have the SMTA and you have a multilateral system, even though that is much, 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 much better, let me tell you, you don't have it as bad as the Nagoya Protocol. Just from a practical implementation point of view. I support the principles of access and benefit sharing. So when I'm negative about the protocol, I'm negative about the implementation and the inefficiencies, just to be clear. But you still have a marketplace, right? Which means the path of least resistance. Water will always take the path of least resistance, and so will a scientific researcher, and so will a commercial developer. They have a fiduciary obligation to their shareholders. If they have the opportunity to source from non-restricted material versus material that has obligations from it, every lawyer in their corporate counsel will say, go use the stuff where there's no obligations. And that's our point with the decoupled thinking, is to say, if you say only this DSI, but not this DSI, that multilateral fund, whatever it is, won't work. It has to be decoupled from the data set or from individual sequences, and says, if you use DSI, point, stop, I'll stop. If you use it and you have commercial intentions and you have income above a certain level, then you have obligations. Go pay here. You know, and of course, there's a lot of devil in the details still to be done. But if you create the opportunity for jurisdiction shopping, for saying, I can go another path of least resistance,
That's where they'll go, yeah.
then that's where it breaks. And that's the same reason also that we argue for a mechanism that is the same for different kinds of organisms. Because if you want to work on, let's say, glucose metabolism, you also have you can also jurisdiction shop across the tree of life. You have to make the system simple, complex, and universal in order to avoid a marketplace effect of avoidance, basically. My 2 cents. I mean, there might be other experts that disagree, but I think that's the fundamental paradigm that policymakers need to wrestle with.
Yeah. We have 2 more questions. Does the DSI on genetic resources, the DSI that were found on genetic resources prior to CBD Nagoya Protocol coming into force, when free exchange of germplasm was allowed, does that DSI fall under benefit sharing then, if there's a benefit sharing agreement?
No. Yeah, no, it doesn't. And in fact, I should say, there are countries that do regulate DSI on a bilateral basis through PIC and MAP. And even in those cases where it is clearly regulated, right now, it's basically the wild, wild west in the databases. I don't know of any countries except maybe, as we discussed yesterday, Yanni, maybe Peru and their biopiracy committee that are actively sort of browsing the databases and the patent literature to look for whether or not you've used Peruvian DSI and have obligations. But this is the point, these international mechanisms only work also when you have user compliance in country. So the answer to that simple question is no, definitely there's no benefit sharing obligations if it's all pre-CBD. And even in real life, even when there's very clearly DSI benefit sharing obligations happening, there's just no enforcement, which is why we're negotiating it right now. Yeah.
So our last question for today, gene banks sometimes don't have resources from, or have resources from unknown origin, so they don't know where it came from. How does that fit in with the DSI? If the gene bank itself doesn't know the country of origin, how are they going to categorize that as some of the passport data that needs to get in there?
Yeah, I mean, the simple technical solution I can say as a collection manager is to look for proxy information on date. If you can figure out the date of entry into the collection and see if it predated the CBD, that is where I think about 50% of, or 60% maybe even of our material, just simply by temporal scope, outdated the entry into force of the CBD. That's the easiest exit path. If you can't find any information on temporal scope, then you do, of course, need to look for any kind of information you have, like an accession form, any information in publications about maybe when this resource came into material. If you know nothing and you really can't find anything on temporal or geographical or person or any kind of a paper trail on that organism, well, somebody was managing your collection pretty poorly. But okay, leaving that aside, you fall into the Article 10 space, which is, okay, assuming that it's not an Annex 1 or an MLS thing, if it's in the CBD space, areas of unknown origin or transboundary situations is Article 10. And in the Article 10 in the Nagoya Protocol is the global multilateral benefit sharing mechanism, which is also going to be negotiated in parallel. Again, it's a recurring theme at the CBD at COP15. And the idea of Article 10 is that when countries could not figure out where stuff came from, and that's where collections were, you know, the bullseye target they were looking at, that they still wanted to claim some kind of benefits from them. And they said, okay, all the leftover soup that would normally land in the stew, that stuff should go through Article 10. And then many countries also have proposed using Article 10 for the DSI solution. That's also not likely to happen because then CBD party countries that aren't parties to the Nagoya Protocol would be left out in the cold, and they're not happy about that. So it'll probably not, the agreement that will be reached at COP15, whatever it is, will likely be at the CBD level and not underneath in the Nagoya Protocol level, just because of the politics of it. So Article 10, I've now gone far beyond the scope of your question, but will likely not come into play for DSI.
That's all right. Well, we have two popped up questions. Do you think we should continue, or do you have other things that you need?
I can make them real quick. I love questions. If I'm not boring everybody, and people have to drop off, they drop off. They already are. So yeah.
Do you think that scientists need a new treaty deal with DSI, or maybe other types of information, if decoupling the DSI and tangible genetic resources?
Yeah, do we need it at all? I think scientists don't want it, but yet we are faced currently with a tremendous amount of legal uncertainty. I mean, both as collection managers or as practicing researchers, we live in a digital age. Yeah, I mean, every one of you has probably a cell phone lying right next to you. We live in an age where information is accessible, and we live in the genomics revolution. We live in a big data world. And if we keep saying, no, 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 don't touch us here, sequence data shouldn't be part of benefit sharing, well, then we're basically saying that benefit sharing shouldn't happen, because our field is happening in the digital age, and that is the lifeblood, growingly so. And so if we say, okay, never touch DSI, never touch information, we're basically saying because benefit sharing is really inefficient and we don't want to mess with it. So I think, and this is actually a great question to link it back to my title, I think it's an opportunity for positive change if we are able to find a simple, non-bureaucratic solution. And the light at the end of the tunnel, and this is a hugely, politically impossible task, but let me just plant the seed, no pun intended. If you could eventually also get, if you got a DSI mechanism that was decoupled and that worked well, and that parties said, oh, wow, this is really working, you could even imagine at COP20, that you could get to the place where even physical biological resources might eventually fall into or be brought into a system that was well functioning and working for everybody. That you open the door, and if the door leads to nirvana, I mean, in the ABS space, it's not hard to get much better, that you could even maybe bring in and restore historical inefficiencies. And that is ultimately why I invest so much time here.
Yeah. Good question coming up, short one. Other than considerations at the country level, what about indigenous nations and communities? Yeah. That's a whole level of rights to materials that we haven't even covered. Most of your graphs cover country of origin as established countries. What about Amazonian communities? These very diverse. How would you have their pick and match to this issue?
I mean, everybody, again, if I can give a rather unfiltered opinion here, everybody thinks that the Nagoya Protocol was like great for IPLCs, or maybe some people do, because it's mentioned and traditional knowledge is officially part of or associated traditional knowledge is officially part of it. But actually, it's not super empowering. Yes, IPLCs give prior informed consent, but actually it's still, unless the government completely gives up its sovereign rights, which it usually doesn't do, even the government, the Ministry of Environment, still, even after IPLCs give prior informed consent, still is the actual owner of the genetic resource. So as long as that is still the construct, IPLCs are still sort of beholden to their governments in a legal context. And I mean, one idea that we've put forth in this paper is just a couple of sentences, and it's under review, so it's not even a citation I can give you. But in this that last graph that I showed you, the decoupled framework, one idea is that you could tag the data with IPLC information, either a generic IPLC tag, just like you give country information, and that might lead, in the database space, at least to the ability to do more quantitative investigation and to figure out what's happening with data that came from IPLC. And it should be a non-exclusive tag so that you can see both country and if it came from IPLC territory, but at least it would start to install some transparency. But I would totally agree with the question asker. This is a majorly unresolved issue that is not likely to go away, or even probably to be fixed by the current discussion.
Yeah, that's a hard one. This is a yes and no answer, and it will be our last, I promise. From Hannes Deppenwolf, do you see any appetite by negotiating parties to go with a subscription type system where countries cover the subscription fees with some sort of multilateral fund?
I think they're not there yet, which is to say the subscription model, be it that the countries that pay or that institutes pay, is definitely on the table. But you have to remember, when negotiations start, they go back basically to square one. They go back to Egypt 2018, and they pick off, right? These are the first official negotiations since November 2018. And a lot's happened in between there. Yeah, August 2021. And so they basically are now at the stage of what is the framework? And what I see happening is they're going to say, the criteria for benefit sharing around DSI is open access and multilateralism. That's, I think, what the, and then maybe a couple of other things, biodiversity, and yeah, who knows, there'll be other details in there. And then once they've agreed on that, then either by COP, like at the next decision, they might add some more details, and they'll include potential modalities, such as subscription fee. And the African group is also pushing very much a 1% surcharge, basically, for biodiversity use. So there's a couple of models floating around, and I think that it's likely there's going to be modalities that are available, and either they're going to push really hard that they're going to have to pick the modalities by COP15, that's what the African group wants, or the decision on modalities is going to go into a decision process for the intersessional period, which means between 2022 and 2024. And they'll only agree on, 2 or 3 principles around DSI benefit sharing. That's my crystal ball, but we don't know yet. I hope that's helpful. So, yeah.
Thanks, everybody. Thank you, Amber, for such a candid, wonderful talk.
Yes, and thank you for the great questions. So fun.
And we hope to hear from you again. To the Crop Trust people supporting us, Faye, thank you very much, and everybody else for negotiating the questions and so forth. And to you, the participants, we hope to see you next month. Stay safe and be well. We'll see you next time.
Thanks
Bye-bye.
again. Bye, everyone.
Bye.